Hi and a very good morning to Sir Chen. My groupmate and I has choose the topic of application of differentiation. So today we would like to present how do we solve our problem using the maximum and minimum method.
Differentiation can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular functions. In this case, we use to find the area. There are 6 steps to apply the differentiation into maximum and minimum values. Step 1, we must understand what is the problem. We must first know the 3 things, which is what is the unknown. The second is what are the given quantities, and the third are what are the given conditions. Step 2, we must draw an appropriate figure and label the quantities relevant to the problems. Step 3, we must find a formula that is suitable for the problem for the quantity to be maximized or minimized, and use the condition stated in the problem to express the quantity as a function of one variable, just that y equals to x, fx. Step 4 is we must find x when the first derivative dy per dx equals to 0, and we must let x equals to c. Step 5, we must find the second derivative if the second derivative is larger than 0, meaning that y is minimum at x equals to c. But if the second derivative is smaller than 0, then y is maximum at x equals to c. And the last step, which is the 6th step, we must insert x equals to c into the y equation to get the maximum or minimum value for y.
The problem statement is, what is the dimension of the quarantine center with maximum area that can enclose with 410 meters? Good morning, sir. I am the representative of the medical staff from the quarantine center Kuching. I would like to complain about the quarantine center where it is getting more crowded with COVID-19 patients and there are not enough beds and spaces for the patients. Could you help to solve this problem, sir?
Yes, thank you for informing us. And we are already thinking about how to solve this problem, since there are already a lot of complaints and reports to us.
Thank you for your attention, sir. We are so grateful for the government support.
Good afternoon to the both of you, CAROLYN and Eleyena.
Good afternoon, sir.
Good afternoon, sir. Why do you call us to join your Google meeting?
Okay, the reason that I've called the both of you to this meeting is to talk about a new development plan that both the high-ups and I have been planning for quite a while. Can I trust the both of you to take over this plan?
Yes, sir.
Sure, sir. You can trust us.
Yes. But what kind of the new plan of development you want to talk about?
As you guys know that we have been quarantined for a long time because of the COVID-19 cases have been keep rising in the terms of number. Therefore, there have not been a lot of place to put them into quarantine. Therefore, this new development plan is to make a new and bigger quarantine center. So do you think that the both of you can take this job?
Sure.
Yes, sir.
But do you have any requirement or condition that you need for this quarantine center?
Okay, the condition that the high-ups and I have been talking about is to make the base of this quarantine center within the perimeter of 410 meters. So, how long do you guys need to make this plan and show it to me?
Within a week.
Within a week.
Yes.
Then I shall wait for one of your best work to show to me within a week. Thank you both of you for your time, and I hope
Thank you,
that you stay safe.
Thank you, sir. Stay safe. Have a
Yes,
nice
sir.
day. Hi, Carol. Good morning. Did you have breakfast this morning?
Yes. And how about you?
Already. So since both of us already breakfast, let's start our planning for this quarantine center development plan. So firstly, based on what Sir Dennis said, he wants the maximized quarantine center with perimeter is 410 meters, right?
Yes.
So to build the dimension of the quarantine center with 410 meters, we need to know how much the length and width. So what if we use the application of maximum and minimum to solve the problem.
Sounds like a great idea.
Okay, so we take this unknown length as x and this width as y. Did you agree?
Yes, it's a good idea.
Okay, so for the first step calculation, we take the 2x plus 2y equal to 410 meters. This 2x and this 2y each come from the perimeter of this base quarantine center. Then we make the y in terms of x. So from my calculation, y in terms of x, the y I get is 410 minus 2x over 2. Okay, so for the step 2, to maximize area, we need to use the formula of an area, which the formula is length times width. From this equation, from the step 1, we already get the value of y. So to simplify this equation of area, we replace the value of y that we found earlier into this y, which is x times with 410 minus 2x over 2. Then we simplify it. After we simplify it, the area that we get is 205x minus x squared.
Okay, so for the next step, we will differentiate the functions of area and we get that dA over dx is equal to 205 minus 2x equal to 0. So after we calculate it, we will get the value of x is equal to 102.5 meter. So when you substitute the value of x into the first equation, which is y equal to 410 minus 2x over 2, you will also get the value of y equal to 102.5 meters. Okay. To find the maximum area of this quarantine center, we differentiate the functions of the area for the second time, and we get d square a over dx square equal to negative 2, which is less than 0. Thus, the area of is maximum when x equal to 102.5 meter. Therefore, to maximize area of quarantine center, its dimension is length and width equal to 102.5 meter.
So, from our calculation just now, the total area of the quarantine center, which is length times width, 102.5 times 102.5, we get 10,506.25 meters square.
Let us present this to Miss Karen and Sir Danish this evening.
Okay, see you this evening, Carol.
Bye!
Bye-bye. Good evening, sir and Miss Karen, and also my partner, Carol. Nice to meet all of you. So, from our both discussion this morning, to get the dimension of the quarantine center with maximum area that can be enclosed with 410 meters, we are applying maximum and minimum method.
Oh, yes. And from our calculation, we get that the dimension of quarantine center with maximum area that can be enclosed with 400 meters is the length and the width is 102.5 meters. So this picture is an example to show how large the area needed for the quarantine center. Does the plan for this quarantine center satisfies the requirements of Sir and Miss Karen?
Yes, it does satisfy my requirement.
Yes. As a conclusion, by applying maximum and minimum method, we are able to achieve the objective, which is to build a new quarantine center. And the perimeter given to build the quarantine center is maximized.